So we're talking about section 5.4, and that's where we're going to begin solving right triangles. Now, before we do, let's have a quick discussion about significant digits. Are you guys familiar with the concept of significant digits? Have you covered that in maybe a different course? Usually science is where it is emphasized the most. The idea is if you understand significant digits, it ought to give you a guideline on how you would round your answer so that everything is pretty consistent. All right, so just to kind of give you an example, if we were looking for, say, the height of a building in feet, and we were using a right triangle, so we're using trig, and maybe the distance from where the surveyor is getting an angle to the top of the building, let's say he's standing 57.2 feet from the building, okay? Because the distance from the building is measured to the nearest tenth of a foot, we would want to round the height of the building the same way because our measurement was only accurate to the nearest tenth of a foot. So we would want to give the measurement of the building to the nearest tenth of a foot. So here's the basic idea. If you were to think of what does this number look like, the way they would typically explain it is if you put it in scientific notation, which means that if you wrote 62 in scientific notation, that would be the number 6.2 times 10 raised to the first power. Because scientific notation simply means that we're going to round this thing, not round, I'm sorry, write it so that there's only one digit to the left of the decimal, and then we keep every other digit that we encounter unless there are zeros at the end, and we don't keep extra zeros at the end. So if we turn that into something in scientific notation, it would be this number, and what number is being multiplied times 10 to some power, we just count up how many digits are here. There are 2. The easy way, I mean, basically, if it's not in scientific notation, you start at the left, and you're going to count every digit until you get to something that is a 0 if it's at the end, and if it's a 0 at the end, we won't count it. If it's any other number, we do. So if I look at these numbers, how many significant digits would you say are here? 2. They both have 2 significant digits, all right? What about here? 52 degrees, 30 minutes. How many digits do you think that would be? Well, it's 4 if we count the 0, but if the 0's at the end, do we count it? So I believe that's going to be 1, 2, 3. This is how many? 3. They're both 3 significant digits. All right? If something is written to where minutes are included or the nearest hundredth of a degree, how many significant digits do you see here? There are 4. And then check this out. This is where your minutes actually get divided into smaller units and get turned into seconds. Or if you're writing it as a decimal value of a degree, it would be to the nearest thousandth. You'd have 3 places to the right. How many total significant digits are in these numbers? 5, because remember, we don't count that 0 because it's at the end. Does that make sense? So if we're trying to solve for missing parts of a triangle, we'll pay attention to significant digits so we know how to round. And if you have questions, you can ask and we'll practice. And it's not a huge emphasis in this course, but as I said, particularly in science classes, that's really? Okay. Did I say anything different from how they explained it?
I think it's after a decimal. Like if you have like 100, like you had a number, and something, the end of that 0, because it's after the decimal, you count.
Even if it's at the very end?
So I know you count the middle. You don't count the beginning of the zeros because we're doing like decimal.
Correct.
So you don't do these zeros. The first non-zero you count. Then the middle 0.
Correct.
And I believe, not unless I misread it,
Okay, yeah, double check on that, because typically you would not count any that are extra at the end, but you do count any that are in the middle. So that's why, for instance, on this one, 60.4, it's 3 significant digits. So if you end up with something from a different, and I know, Jimmy, you shook your head, you were familiar with this, what I just explained, did that match what you understood significant digits to be?
Well, last time I talked about it.
Okay, so it's been a while. All right, just let me know if you, because I don't want to have a different rule that we're following here. Yeah, if you find out there's an issue, let me know. But this would be the way that I believe they're going to expect us to do our rounding. Now, solving triangles. We practiced on an example problem earlier, and we figured out there's a heck of a lot of missing parts you could have, especially when there's more than one triangle in your figure. And so if we need to solve a triangle, it simply means we are going to find the measures of all the angles and the lengths of all the sides in the triangle. So we can find every single missing part. In any triangle, how many angles will there be? 3. Good. How many sides will there be? 3. Okay. So look at this. We have no diagram given to us. And we're supposed to solve this right triangle when we're given an angle and a side. Now, first of all, since there is no diagram, what do you think would be a very smart thing to do? Draw one. Excellent. So I'm going to sketch a right triangle. Doesn't matter which way you turn it. I just need to have a right angle in here. And here's what it tells me. The angles, because this says triangle ABC, so the capital letters represent angles, lowercase letters represent sides. So my angles are going to be angle A, angle B, angle C. What it tells me is that angle B is 28 degrees, 40 minutes, and side A is 25.3 centimeters. Okay? Now, I need to figure out how to set this thing up. So I'm looking at this, and angle B, let's say this is angle B right here, and it is 28 degrees, 40 minutes. Now, this is important to know. The side that will be labeled side B has to show up where in this triangle in relation to angle B? It's got to be across from it. So if this is side B, this over here is going to be angle B. Okay? Now, I also know if this is 28 degrees, 40 minutes, and this is 90 degrees, I should be able to figure out what this angle measure is, don't you think? Okay, so here's what I believe I would know if this is angle B and they gave me the side length of A, okay, then I am going to put side A right here and angle A right here. This is going to be, my right angle is C, and A has a length of 25.3 centimeters. Okay. And that would mean that this side has to be what letter? C. Okay. So we got to find all of these missing parts. Let's, first of all, find what angle A is. We already know angle B is 28 degrees, 40 minutes. Angle C is 90 degrees because it's our right angle. How am I going to find angle A?
Right, 28 degrees, 40 minutes from 90.
Very good. I know angle A and angle B would have to be complementary. So if I were to take 90 degrees and subtract 28 degrees, 40 minutes from it. Now let's see if you remember how to do this. I am going to need some minutes over here. So how do I get that? I got to borrow. So this 90 degrees will turn into 89. This is going to be 60 minutes. Tell me what angle A's measure is going to have to be. 61 degrees, 20 minutes. Agreed? Because if I subtract this out, that's what I'm going to get. All right, so I have found all of the angle measures. I know one side length. That means I've got 2 more side lengths I need to figure out. What do you think? How could we figure out this, one of the side lengths? How could I get maybe side C, that hypotenuse? If I know this side and now I know all the angles. How could trig help me? What kind of trig ratio would involve the hypotenuse? I've got several options. What's one of them? I've got sine, cosine, and their reciprocals. I'm kind of thinking, because they gave me side A, and I know what that is, I probably need to use a ratio that's going to involve this side and this side. Now, I could either use angle A and use which ratio? That would be opposite over hypotenuse, which is sine, or I could use angle B, and that would be which ratio? Cosine, right? Because adjacent over hypotenuse would be cosine. Since they gave me angle B and they gave me side length A, wouldn't it sort of make sense to go ahead and use cosine, because that would mean I've got fewer places I could have made a mistake. If I used angle A and I goof up here, I'm going to get side C wrong. So why don't we use the angle B they gave us, the side A they gave us, and we'll use cosine. And that would mean the cosine of angle B should equal the ratio adjacent, which is 25.3, over hypotenuse, which is C. Okay, now to get the cosine of angle B, because angle B is 28 degrees 40 minutes, that is not a special right triangle. I'm going to need to use what? My calculator. So I need to get a approximation for the cosine of angle B. So let's do this. I'm going to hit cosine. And we said that angle B was 28 degrees in 40 minutes. How do I type that in because of the minutes? I need to type what? And by the way, should I double check to be sure I'm set in degrees? I would. I am, so that's good. All right, so the cosine of 28. Now, how do I put in the 40 minutes?
The second cosine.
You would need to type plus and then put in the fraction 40 over 60. Remember? Since there's 60 minutes in 1 degree, and I have 40 minutes, then I have 40 over 60 degrees, okay? Now, that has given me this value, 0.8774255, blah, 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 blah. One thing I do want to point out, to maintain accuracy, use given information as much as possible. That's why we chose cosine. And avoid rounding in intermediate steps. So what that means is, when I get this value for cosine, I don't want to round it 2 places to the right of the decimal or 3 places to the right of the decimal. I need to keep as many digits as I can while I'm working in the problem. And then at the very end, I'll use my significant digits. Make sense? So I would say let's keep at least 5 digits to the right of the decimal. I'm probably just going to keep this in my calculator, and I may just write down 5 digits on my paper. So I would have 0.8774, and then the next digit is going to be a 3, is equal to 25.3 over C. But I'm supposed to be solving for C, so how am I going to do that?
Multiply.
Yeah, you could either turn it into a proportion and solve it that way, or you could multiply both sides by C, which is going to cause this to cancel out over here. Now this side is C times this, and to get C by itself, won't I divide both sides by this cosine value? So basically, I'm going to have to, in my calculator, take 25.3 and divide it by this cosine value. So let me show you how you can keep up with all these digits in the calculator if you prefer to do that. I need the 25.3. Notice I haven't hit anything since I just found that cosine value, and I'm going to divide it by, and I want to pull up all these digits. If you don't know how to do this in these calculators, it is so cool. If you notice, there is above the little negative sign, it says ANS. If I hit the second and that negative sign, it will pull back the answer from the problem I solved right before this. So that way, I don't have to re-enter all these digits. I don't have to round. It's going to keep all of them for me. And now when I hit enter, I'm getting this number for the length of side C. Now, how many digits do you think we need to round to? This is where significant digits come in. What do you think that needs to be? One place to the right of the decimal. So what would we say is the length of side C? And we need to put a unit on it. It's centimeters. Good job. So they gave us A. It was 25.3 centimeters. We found C. The only thing left to solve for is what? Side B. So we have all the angle measures over here. Now we're finding all the side lengths over here. So what would you want to do to find side B?
Did you just take that from that box?
Well, that works if it's a 30, 60, 90. Is this one a 30, 60, 90? No, so I can't use that shortcut. That's a good thought. If I knew it was a 30, 60, 90, that would save me some time. I'm going to have to use another trig ratio. Which one do you want to use? Okay. Pythagorean theorem is an option. You can use Pythagorean theorem. If I wanted to use trig ratios, though, remember it said use as much given information as possible. If I use Pythagorean theorem, I'm using a side they gave me, but then I'm using the answer I just got. And if I made a mistake on this answer, then for sure I'm going to get this part wrong. If I think about it for a minute, they gave me angle B. They gave me side A. So if I'm looking for B, I could use what ratio? I could use tangent. So I could say the tangent of angle B would be equal to, what's that ratio? Tangent is what over what? Opposite over adjacent. My opposite side is B, over my adjacent side is A, which is 25.3. Now, the tangent of angle B, since angle B is at 28 degrees 40 minutes, I'm going to go back in my calculator, I'm going to hit tangent, and in parentheses I'll put 28 plus, and then in another parentheses I'll do 40 divided by 60. And there's the tangent value with all those digits, okay? So that would mean 0.54673, if I write down 3 of them, is equal to this. Now to solve for B, all I have to do is what in this equation?
Multiply on B, divide by the decimal point. This is the decimal point, 125.
Well, now be careful. Wait a minute. I've got two options. To get B by itself, I can either multiply both sides by 25.3, or if I think about putting this over 1, when I cross multiply, B is going to equal whatever this times this is, okay? So just make sure, whichever way you think of it, if you like proportions, then set it up as a proportion and cross multiply. If you have your variable on top, then it's really easy to just multiply both sides by whatever the denominator is you're trying to get rid of. So this is all I've got to put in the calculator, is this tangent value that I already have there, and multiply it times 25.3. So if I just hit times, it automatically pulls up the answer I just found because it's going to multiply what I just found by, and now I'll tell it 25.3. And what am I getting for the length of side B? Using significant digits, that would be 13.8 centimeters. But I'll wait until the very end to use my significant digits. All right, does that make sense? All right, takes a little practice. Were there other ways we could have found these missing parts? Absolutely. In fact, if you wanted to use Pythagorean theorem, you can, but I want to show you something here. C is our hypotenuse. So we would have a squared plus b squared equals c squared. And c we had already found at this point when we were looking for b. We didn't know b. And a was the 25.3, and that was being squared. Now, let's just see how accurate this would have been. If I were to take the 28.8 squared, because basically if I'm solving for b, it's going to be the 28.8 squared minus this 25.3 squared, right? And then I will take the square root of each side. So I'm going to take the 28.8 squared minus the 25.3 squared, and it's that number. And then if I take the square root of that number, look what we got, 13.76. Will it round to 13.8?
Yes.
Yes, it did, but it kind of just barely rounded to 13.8, right? Because if you had had a 4 after the 7, we wouldn't have rounded it up. If you remember, when we did this using trig, we actually got 13.83. So all I'm cautioning you on is if you use those rounded values that we found and try to use Pythagorean theorem, it's possible your answer could be off just a hair because of rounding. That's why we want to use what they provide to us if we can. Okay, turn the page. So here's another one. But this time, instead of giving us one angle and a side, they're just giving us two sides. So can you figure out how we want to set this thing up? What would you do first?
Draw.
Let's draw this thing. So I'm going to draw a right triangle. And here's what I know. I have a length for A and a length for B. And again, because of the A, the B, the C, and the C is hypotenuse in Pythagorean theorem, we're going to say that the right angle is C. That's going to mean this is side length C. And angle A, or I'm sorry, not angle A, side A is 44.25 centimeters. And side B would be 55.87 centimeters. So tell me something. Which angle would this one have to be? A or B?
A.
Good, because it's the angle that's across from this side. So this is going to be angle A. This is going to be angle B. Now, let's look at it and think. What would you want to find first? Yeah.
So in this one, when you use it like C, I'm not going to find the angle first, but you use Pythagorean theorem if you were given this side.
What do y'all think? Cassidy just asked, because they gave us the two sides, could we use Pythagorean theorem to find side C? Absolutely, because they gave us two sides. So Pythagorean theorem would be a good option for finding that third side. So let's go ahead and do that. A squared plus B squared equals C squared. So we're going to put in the 44.25 for A, square that. 55.87, square that for B, and that's going to equal C squared. All right, calculator time. 44.25, we're going to square it, plus 55.87, and we're going to square that. And that's the number I have. So to get C, I will do what to this number? Take the square root. So I'm going to take the square root of that number. And this is what shows up on my calculator. Now, I do need to pay attention to significant digits at this point. How many digits to the right of the decimal should I go? 2. So this is going to be how long? 71.27. And what was my unit? Centimeters. Good. Okay, so we have all 3 side lengths now because they gave us 2. We found the third one. But we've got 2 more angles that need to be found. We know C is a right angle. So which one do you want to solve for? I don't think it really matters. You want to go for angle A? Because if we go for angle A, we can use what ratio? I know this side and I know this side. That's tangent. Good. So to get angle A, the tangent of angle A is equal to opposite, 44.25, over adjacent. Okay, so I can go to my calculator, and that 44.25 divided by the 55.87 is that decimal number. So here's what I know. The tangent of angle A is 0.72902 if I write down 5 digits, but I'm going to keep all these in my calculator for right now. Oh my. I know what the tangent ratio is. How do I find the angle measure? I have to somehow get, if I had an angle, if I knew what the angle was and I took the tangent, this is the answer I would get. What lets me undo taking the tangent to get back to the angle? Do you remember? You were kind of giving me a clue about it a minute ago. Do you remember what it was?
Yeah.
The inverse tangent. Very good. The arc tangent or the inverse tangent. In other words, just like a square root undoes a square, if we want to get back to the angle measure, then we would take the arc tangent of the tangent of angle A, because this is saying that you would take the angle, find the tangent, but then this is saying find the angle whose tangent is. So basically this cancels that out. And if I take the arc tangent on one side, what do I have to do on the other? Same thing. That's one of the main rules in algebra. As long as I'm doing the same thing to each side, that's legal. So I'm taking the arc tangent of each side. And I'm doing that because this is going to find angle A for me. And this is going to be what goes in my calculator. Does that ring a bell? And how do I get to the arc tangent in my calculator? What do I press? That's where you use the second and then hit the tangent button. So I want to know the angle whose tangent ratio is this nasty decimal. So I'll hit second answer to pull up all those digits. And if we're looking at angle measures, they didn't provide any angle measures to me. So if we're looking at significant digits, I'm going to use what I see here. So I would want to write down what angle measure. Do I want to just make it 38 degrees? Or do I want to keep 4 significant digits just like I have 4 significant digits here? I think I'd go ahead and keep 4 significant digits. So we go 2 places to the right of the decimal. And this would be 38.38 degrees, right? Now, that's if I write it in decimal form. Would you be able to turn this back into degrees and minutes? How? How do I get that 0.38 into minutes? Do I divide it by 60? Let's pick something that would be easy to figure out. Let's say this was 38.5. All right, what is 0.5 of a degree? How many minutes? 30. Do I do 0.5 divided by 60 to get 30, or do I do 0.5 times 60? Times, because this is the decimal amount of a degree I have. Up means I multiply. So in my calculator, I would take 0.38 times 60, and that would give me about how many, because this one I'll have to round to the nearest whole number because I'm trying to figure out how many minutes it is. And that would be 23, there you go, 38 degrees, 23 minutes. Now, do we need to use trig to get the third angle measure? We can, or we could do what? Yeah, find the complement of this. If we wanted to take 90 and subtract 38 degrees, 23 minutes, we could certainly do that because, I mean, you can set it up with another trig ratio if you want. You could actually get the cotangent of the other angle, or I guess you could do the tangent of angle B if you wanted and find that. But if I wanted to solve this, I would change this to 89 degrees, 60 minutes, and that's going to mean that angle B will be what? Looks like 37 minutes. And then this would be 51 degrees. Make sense? Okay. Now, let's talk a little bit about angles of elevation or depression. Angles of elevation and depression are useful. You know how I mentioned a minute ago, if you were surveying, if you were a surveyor, and you've probably seen them on the side of the road, where they have their little cameras set up, and what they're doing is they're really using trig most of the time to find distances on things. But you could measure up to the top of a building that's obviously probably a little hard to get a tape measure and measure how high that building is if you want, or a tree. And you could use an angle of elevation if you wanted, and use trig to help you find missing heights. Think about pilots. If you're flying way up in the air, a lot of times if you listen to the readings that they're given, it often will involve an angle of depression. So you think about their line of sight to the horizon, and if they're looking down, there's going to be an angle that's formed there, and that's called an angle of depression. So these would be some real world things, but what you have to make sure is that the angle of elevation will always be the acute angle formed by whatever the ray is, x, y, and a horizontal ray with an endpoint at x. In other words, it's always going to go from the horizon. If you're up in the air, it's got to be from the horizon down for an angle of depression. Or if it's an angle of elevation, it's probably going to go from the ground up, or maybe from a line of sight up, depending on where you're measuring from. And so the same is going to be true with an angle of depression. It's always measured with that ray and the horizon. Okay? You got it. It is a horizontal line. So most of the time, we're going to be putting things on a coordinate plane. So we're going to be talking about things in relation to the x-axis, which is what we customarily do when we're finding angles. But when you see these words, and if you're trying to sketch it, the tricky one to me is when it talks about an angle of depression. You got to think in terms of that pilot. If he's looking straight out, that's the horizon. It's like the x-axis is up above and he's looking down below. Okay, so here will be the steps in an applied trig problem. First of all, you need to do what when they give you this description? What did we do on all these others when they just gave us some information about a triangle? We needed to draw one, so you better draw a right triangle. Draw a right triangle and label it with the information that you're given. And the quantity you're trying to find will need to be labeled with some variable. You can always use X if you choose, or you may decide, that some other letter is more appropriate. That's fine. You just got to pick a variable. Now, use your sketch after you get everything labeled to see if you can come up with an equation that will relate the given quantities to the variable. That's what we did on those triangles. We looked at it and we said, okay, we need to find side B. They told us how much angle B was and what the hypotenuse was, and then we said, oh, okay, that means we could take the sine of angle B and set it equal to that ratio. So based on how you label everything, that's going to tell you what equation you want to use. And after you write the equation, all you have to do is what? Yeah, solve the equation. And then check it to make sure the answer makes sense. That's the one thing you got to be a little bit careful about, because if something happens, maybe you divide instead of multiply, or maybe you get your ratio set up backwards. If you come up with a distance that just doesn't even make sense because it would be illogical, then you need to go back and see if you labeled something maybe wrong or you computed something wrong. So let's look at this one. The angle of elevation from a point on the ground, 15.5 meters from the base of a tree to the top of a tree is 60.4 degrees. Now, could you find the height of a tree? Let's try. What was step one? We need to try to do what? Yeah, draw. So I'm going to draw a right triangle. And this is basically where my tree is. If you want to make a tree, you can. You don't have to. Depends on how artistic you're feeling. And the angle of elevation from a point on the ground, so I know this is the ground, that angle of elevation was 60.4 degrees, right? Okay. So far, so good? Now, what else did they give us that we need to put on the diagram? The 15.5 meters, it says that this angle of elevation came from a point on the ground that's 15.5 meters from the base of the tree.
So that's the opposite angle. I mean, the opposite side.
Well, here's what we got to figure out. Is the 15.5 this distance, or is the 15.5 this distance? Yeah, it wouldn't make any sense to make it this, because that's actually what? The height of the tree. That's what we're trying to find. So I might want to put my X here because I know I'm trying to find the height of the tree. I know this 15.5 isn't the hypotenuse because it tells me that from a point on the ground, 15.5 meters from the base of the tree. That's what's 15.5. Okay, from the base of the tree out is the 15.5. Now, I've labeled it. It's time to set up an equation. What do you think would be the smart equation to use here? All right, I hear one recommendation for tangent. Anybody want to second that motion? Yeah, because they gave us this angle and this side. We're looking for that side. Clearly, that's an opposite and an adjacent. And that would mean the tangent of what angle? What would I write? 60.4 degrees equals, yeah, whatever variable you use. I wrote X, so I'll put X over 15.5. All right, let's see if you guys can solve it. I'm going to see what you come up with. Tell me, when you put this in your calculator, what was the height of the tree? Do we have it? Did you say 7.3? Oh, 27.3. And that would be 27.3 meters. Okay, that's a pretty big tree, wouldn't you say? Considering a meter is about 3 feet long. That's pretty tall. Okay, so that would be how you could find a missing part. Now, there are 2 more examples. I think we'll have to hold off on doing those for right now, but I think